please don't be scared. Please don't take any tension. That will decrease your marks. Okay, if you take tension or if you are scared, it will decrease your marks. Yes, Himanshu, I am a bachelor. Don't worry about it, Shatakshi. Everyone feels that just before the exams, everyone has a little bit of tension, but try to avoid that as much as possible. Okay. Good evening, Abhinav. Vivek, तू उसी का tension ले. Don't take attention at all, Simonish. Hello, Busra. Thank you, Arjun. All right, I think we can start today's session now. Kirti, it's your first time. Welcome to the session. Okay. Can you suggest any strategy for now? Just focus on your strengths. Okay, Shubham, just focus on your strengths. Okay, just focus on your strengths. Don't take up any new topics right now. And I would suggest you don't try solving any new papers. Okay, don't go around solving full length tests right now. It's not the time. Okay. Zero, should you get zero and should get a Gaurav? I'm not sure what you're asking. Right now, don't do it. Okay, just look at a few random questions. Just focus on the topics you are well prepared for. Okay. All right. Thank you, Simonish. I'm glad I was able to help you. Okay, Sruji. All right, awesome. Let's move on. Okay, so today's session we are going to look into matrices and determinants. Okay, I have a lot of few questions which we'll be looking into. This time there's not that many quizzes. There'll be a few questions which I'll be directly explaining to you guys as well. Okay, so before we begin the session, for those of you who are new, let me just introduce myself. My name is Akash Nair. I'm a JEE Mathematics Master Teacher here at Vedantu. I've completed my BTech from IIT Madras, and I've been nurturing students for various Olympiads like KVPI, PRMO, and RMO from the time I've joined Vedantu. Okay, yes, it's a useful chapter. Let's quickly look at the session plan for today's session. So we'll be looking into more or less one or two questions based on all the topics, skew matrices, matrix. Without further ado, let's start today's session. And let me take a quick yes/no poll. Is everyone able to see and hear me properly? Not exactly plug point. I am not going to take a lot of basics. Okay, I'll try to explain it to you guys, all the questions that we are taking, but going into the exact basics is not possible right now. Okay, inverse. Thoda sa concept, small concept of inverse will be used. I'm not gonna teach you the entire inverse. Okay, beautiful. All of you seem to have got seem to be able to see and hear me properly. That's good. All right, let's move on. And just tell me, how many of you, is this your first masterclass? Yes or no? Okay. Vivek, teri to hamesha first year. Little concepts, yes, little concepts. I'll be focusing on that also. Okay. All right, awesome. Okay, a few of you seem to be attending this for masterclass for the first time, but I'm sure a lot of you guys are the regular guys who have also put yes option. Okay, all right, let's end the quiz and let's move on. Okay, and for those of you who are really new, let me just give you a brief introduction about our platform. You can chat with the teachers and students in the chat box. As you can already see over here, all of you are chatting over here. You can chat with me and your other peers as well. Then you can have your doubts instantly cleared with Ashish sir, who's there in the Q&A panel. You can ask him any doubts. He'll be happy to help you guys. And then there'll be also polls with hotspots, live quiz, and fastest finger list. But like every single time, let me tell you, that is not the important thing. The important thing try to do from this session is try to solve a lot of problems and solve them correctly. Okay, guys, then without further ado, let's start today's session. Okay, and let's have a look at the question. Okay, here you go. So I hope you guys are familiar with what skew matrices are. Basics of skew symmetric matrices are, you have X and Y, two skew symmetric matrices, and there is Z, which is a non-zero symmetric matrix. Okay, ghar pe hu Vivek. Now, which of these are skew symmetric matrix? Okay, this question I'm not, see, this is a JEE advanced question. Abhinav, you think it's A? Okay, guys, just tell me in the chat box what you guys think the answer for this question might be. Hello, Sai Kiran. Is it not chapter description? I'm not sure, Sushti, what you're asking about. B, C, A. Okay, you're going for all the options. C or D? Okay, yes, Shatakshi, that's correct. C and D, both options are correct. Okay, both C and D matrices are going to be skew symmetric matrix. Okay, so for skew symmetric matrix, you know what is the condition required? That is, the transpose should be equal to the negative of the matrix, right? Yes, C and D is the correct answer. So transpose should be equal to the negative of the matrix. This is the condition required. Hello, Abhay. So this is the condition that we have, and it is given to us that X and Y are both skew symmetric. So I can say that X transpose is equal to minus X and Y transpose is equal to minus Y. Similarly, since Z is a symmetric matrix, okay, Abhinav, that is the basic definition of skew symmetric matrix. Okay, the basic definition of skew symmetric matrix states that X transpose should be equal to minus X. Okay, if X is a skew symmetric matrix. Hello, Vijay. Similarly, if you have a symmetric matrix, okay, if you have a symmetric matrix, then you can say that Z transpose should be equal to Z. little bit more description of the chapter. So see, I cannot do that right now. Okay, we'll see. The session was planned a little bit advanced level. Okay, so I cannot go for the basics of entire chapter, but I'll try to help you out with all the basic info that is required. As I told you, skew symmetric matrices, x transpose is equal to minus x. Similarly, z transpose will be equal to z. Okay, now let's have a look. So what we have to do is, for all of these sessions, to check whether a matrix is skew symmetric. Okay, to check whether a matrix is skew symmetric, what you have to do is you just have to take its transpose. Okay, you just have to take its transpose. All right, WhatsApp, you can send me a message on the Vedantu website. I'll try to help you out. Okay, you can send me a message on the Vedantu website. I'll try to help you out. Akash, what problem do you have? Okay, so all you have to do is you have to take the transpose. Okay, you have to take the transpose of your function. No, Arjun, I am and from OpenCast. All right, so we just have to take the transpose of the function. All right, we just have to take the transpose of the function. So what transpose of the matrix, that all we have. So just take the matrix over here, you take the transpose, you get the value, and then you will be able to see that once you take your transpose, what you're going to left out with is you're going to get minus of the original matrix. Yes, I am from Kerala. You're going to get minus of the original matrix. Okay, you're going to get minus of the original matrix. That means the option C, the matrix that was given, is going to be a skew symmetric matrix. Okay. Amruta, transpose, you're not familiar with transpose. If we have just used the basic properties of transpose. Okay, so if you have X minus Y matrix transpose, you can take it as X transpose minus Y transpose. Okay, these are few simple properties of transpose. I cannot get into the basics of those things, so you have to just use those properties and just check transpose of the matrices. If you get it as equal to minus of the matrix, you can say they are skew symmetric matrix. Okay, give me a quick poll. Has everyone understood this? Just check out all those values. A and D will not satisfy the conditions. Okay, A and B will not satisfy the condition. C and D will be skew symmetric matrix. Okay, all right, awesome, beautiful. All of you seem to have got it. Wonderful. Let's move on. Okay, now what is an orthogonal matrix? Okay, orthogonal matrix is the condition if A into A transpose is equal to identity matrix. Okay, if A into A transpose, approx kitne questions? 25 questions. Okay, wait, 25 questions. अच्छा, matrices and determinants है two questions. Okay, so here you go. So orthogonal matrix, you have A into A transpose is equal to identity matrix. All right, so what is your identity matrix? Depending on whatever, if you have a 3x3 matrix, this will be your identity matrix, right? Can anyone tell me what is the value of determinant of an identity matrix? Quickly tell me what is the beautiful. The determinant of an identity matrix, is always equal to 1. Okay, so if you have 1 over here, are you able to see if A into A transpose is equal to 1? So I hope you guys know this as well, that the determinant of a matrix is equal to the determinant of its transpose. So the only way in which I can get a product of two numbers being equal to 1 will be if their individual determinants are equal to 1 or minus 1. Hello Saikiran, hello Aman. Okay, are you guys able to see this? That is the only condition that is required. So I can say that if a matrix is orthogonal, which means its determinant has to be 1 or minus 1. Okay, have you understood the basic concept of orthogonal matrix? All right, awesome. All of you seem to have got it. Wonderful. Let's move on. Okay, let's move on and let's have a look at a question. Hello, Sakshi. All right, let's take a question. I didn't point it also. I'll take it, Cycle, and don't worry about it. Okay, so here you go. Here's the question, and there's a small hint also given to you guys. You have a matrix which is orthogonal, where A, B, C are positive, and A, B, C, the product of A, B, and C is equal to 1. You have been asked to find the value of A cube plus B cube plus C cube. All the things that you need is been given in the hints. Try to use them carefully and use the property that we have just discussed and solve this question. I'll give you 2 minutes, but I'm sure you'll be able to solve it much faster. Be careful while you're telling the answer. Okay, be really careful. Okay, many of you have answered, many of you are still solving. Guys, be careful. Everything that you need has been given to you in the hint section. Okay, everything that you need has been given over there. Really few of you have got the correct answer. What mistake are you guys making? Yes, the value of determinant of the matrix is given. You don't have to worry about that. And also small condition has been given over there. Just look at it carefully. Okay, the percentage has went up a little bit, but still, many of you are still making mistakes. Come on, guys. I think I get what mistake you guys are making. Okay, the percentage of correct answers is on a rise, but still too low. Guys, read the question carefully and look at the hints carefully. Everything is given over there. All right. So most of you have already answered. So 15 more seconds. When the timer hits 20, we are going to end the quiz. Okay, last 10 seconds. All right, the time's up. Let's end the quiz. Let's have a look at the fastest fingers list. Okay, none of you were able to solve it correctly. Just 19% of you guys got it right. The correct answer is option C. Okay, guys, so what did you have to do? Since it is given to you that the value of matrix is equal to minus of a cube plus b cube plus c cube minus 3abc. Can you tell me what can be the value of this determinant? Quickly tell me what can be the value of this determinant. Aryan, just a bit, two questions. Okay, all of you went for the trap. Yes, it can be either plus 1 or minus 1, right? There are two options, either plus 1 or minus 1. But what happens over here? Since you have been told that ABC are positive and it is given to you that a cube plus b cube plus c cube minus 3abc is always greater than 1. So, since I have a minus sign put over here, this value needs to be equal to minus 1. Are you guys able to see? This value needs to be equal to minus 1. Okay, you have to be really careful. So I can remove these minus signs. So I get a cube plus b cube plus c cube minus 3abc is equal to plus 1. And from there, I put the value abc is equal to 1. I get a cube plus b cube plus c cube is equal to 4. Okay, you should never, I told you guys, read the hint carefully and solve it. Okay, all right, give me a quick poll. Has everyone understood this? Means ke 3 दिन पहले यार, of course I was also taking a lot of tension, but now I can tell you guys that don't take attention. Okay, plug point, where do you have a doubt? Akash, basic definition of orthogonal matrices. Okay, if a matrix is orthogonal, its determinant has to be plus or minus 1. Okay, its determinant has to be plus or minus 1. Plug point, the first hint, they have just opened up the matrix. Okay, they have just opened up the matrix. Okay, it was just told so that you don't have to work out for that. All right. Yes, Sai Kiran, I will talk about that as well. Don't worry. Okay. All right. Okay, guys, so just open up the matrix, use the condition that a cube plus b cube plus c cube minus 3abc is greater than 0. That will give you a solution. Okay, the correct answer is option C, that is 4. All right, I hope all of you have understood. Yes, of course I was tensed. Of course I was tensed when I was giving my exam as well. Everyone is tensed. Okay, guys, don't worry about it. Okay, let's move on. Okay, let's move on. Let's move on to the next concept. That is idempotent matrix. So what is this? A idempotent matrix has to be a. You're from Tripura. Okay, cool, Akash. Yodhan, where do you have a doubt? Yodhan, we have just used the hints that was given to you over here. Okay, you have just used the concept that an orthogonal matrix determinant has to be equal to plus or minus 1. That is all the only condition we have used over here. And since a cube plus b cube plus c cube minus 3abc is positive, we get the value as equal to 1. Okay, all right. Let's move on. Okay, let's have a look at this. A square matrix. So idempotent matrix, first condition, it has to be square matrix. Okay, it has to be square matrix, and the other condition required is the square of that matrix. So a square should be equal to a. Okay, a square should be equal to a. This is the only condition that is required for a matrix to be called as idempotent matrix. Okay, and now are you able to see that if a square is equal to a, are you able to see that a power n will also be equal to a? Because as I go on multiplying a square, right? So for a cube, I can write this as equal to a square multiplied by matrix A, and over here once again I can use the concept that a square is equal to a. I'll get a square into a. This is equal to a square, which is once again equal to a. Hello Ankita, I'm good. Vishnu, how are you? So you can take this a power n any values. If that matrix is an idempotent matrix, then a power n will also be equal to a for all n greater than or equal to 2. All right guys, has everyone understood this? Give me a quick poll. Fastest finger list? Yes, of course. See, that's why before the beginning of the session, I always told you, right, Raghav, don't focus on the fastest finger list. Okay, don't focus on the fastest finger list. All right, beautiful. All of you seem to have got it. Wonderful. Let's take a simple example. Let's look at this concept, and after that, I'll take a quiz for you guys. Okay, you meant one more question. You then I'm not bought same question for that topic, but don't worry, we have few other questions as well. All right. Vama, you are from Pune, Baramati. Okay, nice joke. All right, so here you go. So we have to show if A is an idempotent matrix, then 1 plus I plus A cube is equal to I plus 7A. Okay, are you guys able to see this? So all you have to do over here is just open this bracket using A plus B the whole cube. So you get A cube plus B cube plus 3A square B plus 3BA square. Okay, then you will just get these values. So one thing is, we know that the determinant of I is equal to 1. So I square, I cube, all of them will be equal to 1. Okay, everything will be equal to 1. And I also know that A cube is equal to A square is equal to A. Use this concept over there. You will get your concept of I cube, I plus 7A. All right, guys, give me a quick poll. Have you understood this? The next question is going to be for you guys to try out. Okay, next question is going to be for you guys to try out. That would be a little bit more better. Okay, last slide. Harsha, where do you have a doubt? Okay, Harsha, where do you have a doubt? Okay, Kirti, I'll try to explain a bit slower. समझ नहीं आया अंकिता कहाँ पे डाउट है okay the only concept that we have used is the values okay the determinant so I multiplied by any matrix is equal to the matrix itself okay I is your identity matrix over here a power n equal to 1 हो जाए उसे क्या कहते हैं वही तो आइडेंटिटी मैट्रिक्स हो गया ना a would be an identity matrix okay a would be an identity matrix all right okay let's move on let's look at a question that will help you guys understand it much better all right here you go Harsha, we have just used the concept of a plus b the whole cube. Okay, we have used the concept of a plus b the whole cube and use the concept that I power n is equal to I. Okay, any identity matrix, whatever power you take, it will be equal to the identity matrix. And if you multiply, okay, if you multiply any matrix with your identity matrix, you will get your original matrix itself. These are the two concepts that we have used to solve the previous problem. Okay, I hope you have got this. Just watch the replay once again after the session ends. For now, let's focus on the next question. So you have A is an idempotent matrix and you have I plus A whole power n. Okay, you have I plus A whole power n and you will have to use a little bit of binomial over here. Okay, you'll have to use a little bit of binomial. What you have to use has been given over there, the binomial theorem, and something extra also has been given for you guys. Try to solve this question. Again, a really easy question. Be careful. Okay, don't go for the fastest finger list trap. 2 minutes, but if you are able to solve it quickly, we'll end the quiz faster. All right, your time starts now. Guys, take some time and solve it carefully. Okay, take some time and solve it carefully. Please don't make the mistake you guys made in the previous question. Okay, this time a lot of correct answers are coming in. That's good. Okay, all of you seem to have solved already. So I'll give 45 more seconds. When the timer hits 60, we'll be ending the quiz. Okay, when the timer hits 60, we'll be ending the quiz. Last 40 seconds. All right, all you have to do is use your binomial expansion and you'll get your solution. Okay, last 20 seconds. Right, last 5 seconds. And the time's up. Let's have a look at the fastest fingers list. This time I'm sure few of you might have solved it correctly. All right, beautiful. Lots of correct answers. Wonderful. 54% of you got it right. Awesome. Okay, yes, the correct answer for this question is option B. All you had to do was use your binomial expansion. Okay, use your binomial expansion on I plus A power n. Okay, use your binomial. Sai Manish, awesome. Okay, net lag हुआ यहाँ वमा quiz खत्म हो गया. So use your binomial expansion over here. You get NC0 plus NC1 into A plus NC2 into A square. Why? Because we have again used the same concept that I into A is always equal to the original matrix itself. Okay, I into A is always equal to the original matrix. That is all we have to do over here. Expand it further, you will get A plus this value. You guys know that NC0 plus NC1 added till NCN will be equal to 2 power n, and since that NC0 is absent, so you'll have to take a -1 over there. Okay, Raghav, a little bit, many students will not be able to solve it without the hints. Okay, try, if you think that you can solve it, just try not looking at the hints. All right, awesome. Give me a quick poll. Has everyone understood this? All of you? Okay, beautiful. Most of you seem to have got it. Awesome. Slowly. Okay, Pranay, I think I am already going slow. Okay, I'll go a bit more slow. All right. Chiru, what doubt do you have? I've not seen a message. All right. Let me end the poll and let's move on. Hello, Shrikar. All right. Bache 90 के around है Vivek. All right, let's have a look at this question. So here you go. So A is a 3 cross 3 non-singular matrix. Okay, such that A into A transpose is equal to A transpose into A and B is equal to A inverse into A transpose. You have to find the value of B into B transpose. Now you'll have to use a property of A inverse into A being equal to identity matrix. Okay, try to use that properties and try to solve this question. I'll give you 2 minutes. Try to solve this one. This time there's no hint. Okay, this time there's no hint. All right. Okay, a few correct answers coming in, a lot of wrong answers also coming in. Be careful, guys. Just open it up. Okay, just open it up. AB whole transpose is equal to B transpose into A transpose. Use a few properties of transpose and inverse. That's all you have to do. Okay, that's all you have to do. All right, lots of you have solved it correctly. Many of you have made mistakes as well. Okay, I'll give you 30 more seconds. When the timer hits 30, we're gonna end the quiz. Okay, a really simple question. All you have to do is you have to just use the properties of transpose and properties of inverse. Okay. And basically inverse, when I'm saying the properties of inverse, what I mean is just A inverse into A is equal to identity matrix. Okay, last 15 seconds. Okay, last 15 seconds. Last 10 seconds. Viswanath, yes, you are late. Okay, the time's up. And let's end the quiz. And let's have a look at the fastest fingers list. All right, few of you got it right. Okay, 38% of you were able to solve it correctly. That's wonderful. Yes, the correct answer over here is B. That's awesome, Vivek. Don't worry about it. Okay, being correct is more important. Okay, being correct is way more important. Okay, yes, the correct answer is option B. All right, all you have to worry about over here is first of all get the value of B transpose. Okay, get the value of B transpose. So that will be equal to A inverse into A transpose whole transpose. As I've already told you guys, when you have AB matrix A into matrix B transpose, this is equal to B matrix into B transpose into A transpose. Okay. Amrita, sound sunai nahi de raha. I'm sorry about that. Okay, you'll get this property, and there's another property that A transpose whole transpose will be equal to A itself. Okay, itni calculation nahi ki. Of course, you don't have to do this many calculation. You can solve a lot of stuff in your mind itself. Okay, just solve them up, play around with these matrices a little bit, and you will be able to get the value of A inverse into A, which, as I've already told you guys, is equal to identity matrix. Okay, and similarly, A transpose into A inverse whole transpose will be equal to transpose. In before question, we may substitute n is equal to 1 comma 2. Then using binomial, check it once. Chiru, yes, a lot of times if your options have been given, you can do that, but you have to be careful. Okay, also try taking at least 3 values and different values. 1 or 2 are but 2 easy values to check out. Okay, transpose into A inverse transpose will also be equal to identity matrix. This will give you identity into identity, which will be equal to identity matrix. Okay, give me a quick poll. Has everyone understood this? All right, awesome, beautiful. All of you seem to have got it. Wonderful. Let's move on. Net will be gone. Okay, Raghav, no problem. Okay, make sure you watch the replay. All right, so let's move on. And now let's have a look at the number of solutions for a system of linear equations. Okay, if you have a system of linear equation, yes, Sainath, what doubt do you have? You have a system of linear equations, basically a1x plus b1y plus c1 z is equal to d1. And similarly, you will have an a2 and a3. You will have 3 equations, right? A system of linear equations. If you have 3 equations and you have to solve them, so what are the conditions required? If the determinant, there is no what this major determinant is, that is nothing but a1 b1 c1, a2 b2 c3, and a3 b3 c3, right? This is your major determinant. If that determinant is not equal to 0, okay, if this determinant is not equal to 0, then you can say that we can solve linear equation by manipulation. Yes, of course, Raghav, you can always solve. Okay, you can always solve, but many times it's a bit, see, if there are 3, so if there are 2 variables, it's always easier to go for the manipulation method. But if there are 3 variables, then it becomes a little bit difficult to use the manipulation method. Okay, it becomes a little bit difficult to use the manipulation method. Yes, this is the Cramer's rule. Okay, plug point, basically determining y in terms of x and z. putting that into another equation, getting an equation in terms of z and x, similarly doing the same thing once again, and solving the equations to get the value of x and z. The thing you do when you have two linear equations, right? If you have 2x plus 3y is equal to 4 and 2x plus y is equal to 7, you use the manipulation to get the value of x in terms of y. That's what manipulation means. Okay, all right. Yes, we can also solve using matrices. All right, so you find your determinant. That determinant is not equal to 0, then you have a unique solution. Okay, if this determinant over here is equal to 0, Pawan, what do you have a doubt in? Okay, and then if the determinant z, x, y, and z, how do you find the determinant x? So over here, you have to replace the first term with d1, d2, d3. Okay, you replace the first one with d1, d2, d3. Teach a faster method. This is the, see, many of times there's no faster method. See, if you have a system of linear equations, you have to observe the linear equation. Depending on the equation that you have, you may have to change. Manipulation might work. Okay, that is the faster method, manipulation, but you should have a suitable example. Okay, if the example is not suitable, then you will have to go for this method. All right, Shrikar, this is the Cramer's rule. This is quite basic and all of you might know about this. Okay, just use the basic concept, get your determinant. If it is not equal to 0, you get a unique solution. If that determinant is equal to 0, okay, you'll get confused when determinant x, y, z happens sometimes. Okay, happens sometimes. All right, give me a quick poll. Has everyone understood all of these conditions? Okay. Yes, Raghav, if all conditions are 0, then it will have no solution. Okay. If all cofactors are 0, then it will have no solution. All right, awesome. All of you seem to have got it. Wonderful. How to calculate x, y, and z? Delta x upon delta. Okay, that's it. All right, you girl. You find your determinant x, divide by whole determinant, that will be equal to x. All right, that's it. All right, awesome. All of you seem to have got it. Let's move on. Okay, let's move on. Let's have a look at a question. Okay, here you go. You have to find when if the following system is given to be consistent. Okay, if the system is consistent, what it means is you have a set of defined solution. Okay, this means basically you have to find the value such that the determinant that we were looking at, that determinant cannot be equal to 0. If it is equal to 0, then your system is going to become inconsistent. Okay, so basic condition that you have to look for over here, take the original determinant, make it not equal to 0, check out which of these values satisfy the condition, and try to solve this question. Okay, I'll give you 2 minutes, try to solve this question. This is a really easy question. Okay, take some time, please don't make a hurry. Many of you are making a hurry, please don't make a hurry. Solve the question carefully. Okay, most of you seem to have solved it. All right, we'll take the entire time. Okay, entire 2 minutes, and then we'll look at the solution. All right, the time's nearly up. Okay, let's have a look at the fastest fingers list. Okay, a few of you have got it right. Okay, option C is the right answer. 30% of you were able to solve it correct. Wonderful. Okay, so you'll have to check. See, what does inconsistent mean? So you'll have to check both of the conditions, right? Whether you have a zero solution or you have to check the other condition where you have infinite number of solutions. Okay, all right. The two conditions are what you will have to check. For the first one, you just have to look for the determinant being not equal to zero. Okay, answer Saita or Mira. That's wonderful, Vivek. Hamesha, as I have told you always, take some time but give the correct answer. Okay, so here you go. So determinant is comes out to be 1 4 1 1 10 2 1 2 s 3 is not equal to 0. Over there you get your condition. Vama, sometimes they know the answer previously और बहुत लोग बस ऐसे आंसर डाल देते हैं. All right, weightage Vishnu, you can expect one or two questions. Okay, two questions fixed, one from matrices, one for determinants. All right, so you will have S is not equal to 8 and T belongs to R. And for the other case, you will have to check for the condition where delta is equal to delta x is equal to delta y is equal to delta z, all of them being equal to 0. Okay, all of them being equal to 0. This will give you the second condition, that was S is equal to 8 and T is equal to 36. Okay, this will ensure that all the determinants are equal to 0. Again, got confused? Take a little bit of practice. Okay, practice a little bit, Shatakshi. I'm sure you'll be able to solve that question as well. Okay, yes, this is a little bit hard. You will have to practice a bit over here. Okay, Shruti, how much slower do you want me to go? I don't know. See, I'm trying to go as slow as possible, but we have to finish all the questions as well, right? Okay, beautiful. Let's move on. Okay, maths कितनी देर में कर ली? मैथ्स मैंने आई थिंक 1 hour 15 minutes के अराउंड दिया था. मेरे को केमिस्ट्री में ज्यादा भरोसा नहीं था, तो आई हैड गिवन अराउंड 1 hour 15 minutes or 1 hour 15 minutes for maths. Okay, so here you go. Now you have to find the determinant is independent of which of these. So whenever you this term independent, basically what they're asking you is they're asking you to differentiate with respect to alpha, differentiate with respect to beta, and differentiate with respect to alpha beta. Now, looking at this equation carefully, okay, looking at this determinant carefully, you'll be able to see that which one of these determinants, which differentiating these determinants, which value will actually give you a zero value. Okay, that is what you have to look at carefully and try to solve this question. Okay, I'll give you 2 minutes. I hope you guys know how to differentiate the determinants. Take one column, differentiate the first column, keep it aside, plus differentiate the second column, keep it aside, and finally add the determinant by differentiating the last column. Okay, I hope you have got this. I'll give you 2 minutes, try to solve this question and get the determinant of value for which of this differentiation will be equal to 0. That will be your solution. That term, the determinant will be independent of that particular value. Okay, I'll give you 2 minutes, try to solve this question, be careful and try to solve it. Please don't make a hurry. Please don't make a hurry. All right, many of you are giving right answer now. That's good. Take some time and solve it as I've already told you guys. Okay, last 10 seconds. Yes, look at it carefully. It's always happy. See which one you have to choose. So options, these options are also quite helpful. So if you're able to get one of the answers to be determinant equal to 0, you don't have to look for anything else. All right. Okay, let's have a look at the fastest fingers list. Okay, a few correct answers. Just 20% of you were able to solve it correctly, guys. The correct answer was option A, alpha. Okay, why? First of all, why did you choose alpha in the beginning? See, are you able to see that the column 3? Are you able to see that the column 3 is completely independent of alpha? Is everyone able to see this, that the column 3 is completely independent of alpha? So when I differentiate this column, I'll be able to get a 0, 0, 0 value everywhere. Okay, that was the first aim about why I went for option A, that is alpha. And once you differentiate it, you will be able to get that the other determinants are also equal to 0. Okay, Shiru, where do you have a doubt? More time, differentiate one column, keep the other two columns as it is. Differentiate the second column, keep the other two columns as it is. Finally, differentiate the last column. Okay. All right, guys. I hope you have understood this. Here you go. So then you will be able to see that the over here the two columns are equal, and whenever you have two equal columns in the determinant, you can say that this value with this determinant will be equal to 0. Again, over here as well, you have two columns which are equal. So once again, you will have that determinant's value being equal to 0. And finally, the last value, you have an entire column which is equal to 0. That will make you, that will give you the final determinant also equal to 0. Okay, so over here you will be able to see that this value is going to be completely independent of alpha, because differentiating with respect to alpha gave you a 0 value. Okay, all right guys, give me a quick poll. Has everyone understood this? Okay, all of you, beautiful. Yes, everything will be covered. All right, awesome. All of you seem to have got it. Wonderful. Let's move on. Yes, Harshwar. Yes, Aryan, what do you have a doubt? Beta check kiya? Okay, no problem, Vivek. Happens sometimes. All right, wonderful. All of you seem to have got it. Awesome. So, guys, that was the last question for today's session. You guys solved it quite fast, so we were able to cover up all the questions quickly. So, if you guys want more, you enjoyed the session, and if you want more, no, it is not independent of beta, Harshvardhan. If you differentiate it, you will not get 0 value. Okay, you will not get 0 value. Okay. Aryan, trivial and non-trivial, when you have homogeneous equation, 0, 0, 0 is actually a trivial solution. All right. So you go. So you can opt for the JEE Pro Lite subscription model that we have started here at Vedantu. So you can choose your own teacher, your own topic, your own time. There'll be multiple micro courses running throughout and modular courses running throughout the time, and you can go for any chapter which you feel a little bit doubt in, and you will have unlimited in-class doubt solving. You'll have test series designed by Anand sir. You'll have 24/7 concept videos, and you will get mentored by experts who have produced AI ranks of 1, 2, 6, and 21. All right, guys. So here's your link. 1 day is left for JEE. Yes, Sana, but you can prepare for the April JEE as well. Okay, so here's your coupon code. You can go on this link and register for the course. Here you go. Let me show this link to you guys. I'll show you the leaderboard. Don't worry about it, guys. Here you go. Here's the leaderboard. So congratulations to all of you guys who are on the leaderboard. Others as well who were able to solve a few questions. Congratulations to you guys as well. I hope you enjoyed today's session. I'll see you in another session. Till then, bye-bye. Take care, guys. Okay.